What causes Docker networking problems, and how can you troubleshoot? Imagine setting up your Docker containers to work smoothly, but suddenly they can't talk to each other or reach the internet. Frustrating, right? Docker networking issues can pop up unexpectedly, especially when you're managing multiple containers or deploying in cloud environments. Let's explore what causes these problems and how you can fix them. First, conflicts in network routes are common culprits. Docker often adds default routes to containers, but sometimes these routes clash with your host's existing network setup. For example, if Docker installs a default route that overlaps with your main network, containers might lose connectivity or experience delays. Checking routes with commands like iproot or root can reveal these conflicts. Removing or adjusting problematic routes can restore proper communication. Port conflicts are another frequent issue. When a container tries to bind to a port already used by another service on the host, it can't expose its service properly. Using Docker port or tools like Netstead and SS helps identify which ports are in use. Changing the container's port mappings or stopping conflicting services can solve this problem. Firewalls and security rules also play a big role. On cloud platforms like Amazon Web Services, Microsoft Azure, or Google Cloud, security groups and host firewalls might block Docker traffic. If container ports or Docker network interfaces aren't allowed through these rules, network connections will fail. Reviewing and updating firewall rules to permit Docker-related traffic is essential. DNS resolution failures can cause containers to intermittently lose access to external resources. Sometimes Docker's internal DNS server conflicts with the host's DNS settings, leading to name resolution issues. Testing DNS inside containers with commands like nslookup or dig can help diagnose this. You might need to specify custom DNS servers in Docker's configuration to fix the problem. Container-to-container communication issues often happen when using default bridge networks. These networks are simple but limited. Creating user-defined bridge networks improves isolation and allows containers to communicate more reliably. Using the Docker network create command helps set this up. Resource exhaustion is another hidden problem. If your host runs out of network buffers or hits connection limits, containers may experience dropped connections. Monitoring system resources and adjusting Docker or host network settings can prevent this. Increasing buffer sizes or connection limits might be necessary. Sometimes, using host network mode can bypass Docker's network stack entirely. When you run a container with network is equal to host, it shares the host's network interfaces. This can resolve connectivity issues but reduces container isolation, so use it carefully. Finally, enabling detailed Docker logging can help identify the root cause of network problems. Increasing log levels and reviewing logs can reveal patterns or specific errors that point to the source of issues. Troubleshooting Docker networking in cloud environments requires paying attention to both Docker settings and cloud security configurations. Making sure your virtual networks, security groups, and firewall rules align with Docker's network setup is key. Using infrastructure as code tools to manage network policies can help keep everything consistent. In summary, Docker networking problems often come from root conflicts, port clashes, firewall restrictions, DNS issues, or resource limits. Systematic checks of routes, ports, security rules, and resource usage help pinpoint and fix these issues. When working in cloud environments, ensure your network policies support Docker's needs. With a little investigation and proper setup, you can keep your containers communicating smoothly and reliably.